that, we can kind of begin. So what I have over here, this is just like a brand new Foundry project that I've set up. I haven't installed any dependencies. I haven't, and I even deleted like the basic counter files or anything like that. So we're just going to start from scratch here. But before we do that, I just want to talk a little bit about what it is that we're going to be building, right? So I'm building your first hook. So effectively, like we're gonna build what is effectively a really, really simple kind of a points program on chain. And the idea is that, assume you have some sort of like ETH slash XYZ token pool on UniV4. Um, so the idea is like uh, you know, as you sort of trade in this pool, um, if you are spending ETH to purchase XYZ token, we're gonna give you some quote unquote points for that. Oops. Uh, right. And the idea is like, a more blown up version of this would be something like, you can kind of treat it as you can build out like a loyalty program over time. People who are doing a lot of these trades, you can eventually maybe charge them lower swap fees, something like that. But for today, we're going to keep it really straightforward and really simple. And all we're going to do is like, you're just going to get some points. What you do with those points is out of scope for today, but I'm just going to show you like a basic high level flow, of how like hooks interact with pools, and a very simple example of like how you can do something here. Um, so you can also kind of think of this points program as, like an incentive for, people to purchase your XYZ token with ETH so that, they can farm these points for XYZ like future rewards or whatever, right? And the way we're going to represent these points by themselves as well, like so points themselves will also be represented as an ERC 20 token. So basically, like earning points is equal to like minting points tokens to the user, basically, right? So every time a user does a swap, depending on how large the swap is, we're gonna mint some points tokens to their wallet effectively. I do want to preface this before we get much deeper. I want to preface this by saying like this is a bare bones proof of concept. You should not use this as it is in a production environment. And we can talk maybe later a little bit about, certain improvements that you might want to make to something like this if you want to like blow it up into some sort of actual idea. But just keep in mind, it's like a hello world thing, right? Um, cool. So we know uh like we know kind of like like how are points going to be assigned. We said, points are going to be an ERC20 token. We're going to mint those tokens every time somebody kind of does a swap to purchase the token by spending ETH. And the other thing we want to ask ourselves is also, before we jump into the coding part, we want to ask ourselves is how many points to give out, right? Like, how do we know how many points to give out? Um, so for today, we're going to keep it really, really simple, and we're going to just have like basically a linear curve. So for every swap that happens, um, we're going to give out basically like 20% of the amount of ETH that was spent as points token. So for example, if someone spends 5 ETH, we give them basically like the equivalent of like 1 point token, right? 20% of 5, give them 1 point token. You can change this however you want, you can have more fancy curves, but this kind of fills the use case and fills the need that we have for today. Um, cool. And there's a couple more things I want to talk about, but we'll kind of jump back and forth between the code and the high level explanation as we go about doing that. So every time you want to sort of, build a hook project, the first thing you kind of need to do is we're going to do forge install Uniswap slash v4 periphery. So, oops. So what this dependency contains, Uniswap v4 periphery, this basically contains, some base contracts that we're going to want to extend. It contains a bunch of libraries that we might want to use. And it also has like a further dependency on Uniswap v4, like the main code base, so we can interact with, the Uniswap protocol, do a bunch of things over there. But pretty much anytime you're going to be building a hook project, you want to have the v4 periphery dependency installed here. And we're going to be using a bunch of stuff from in there. While this downloads, we also need to quickly configure our Foundry environment a little bit. So one of the things you may or may not know is Uniswap v4 makes heavy usage of a relatively new Solidity feature called transient storage. I forget what the exact EIP number was, but it's a relatively new Solidity feature. It only exists in Solidity versions 0.8, 0.25 and above, and on EVM hard fork of Cancun or beyond. So we want to, let Foundry know that, we want to use a specific version of Solidity, at least 0.8, 0.25, use 0.8, 0.26, have that installed. And we want to use a specific EVM version like Cancun or above, right? Like you have the Pectra upgrade coming now, so that is also fine, but it's not there on mainnet yet. So these are like bare minimum things you need to configure in your Foundry environment. Otherwise, your contracts won't compile if you try to use older versions of Solidity here. So we have this installed. They also set up Foundry remappings, and we're going to get rid of all the like default counter files. So let's go ahead and we'll start off with going a bit quick. Sorry. Okay, I'll pause. Do you have any questions? I'll pause. I can quickly recap. So far, what we've basically done, we installed the v4 periphery dependency, right? We Oh, you're writing it alongside. You don't need to follow alongside me because this is recorded. You can follow it later. I would suggest just sort of following it on a higher level and just kind of understanding like what's going on for now. And step by step, like writing it yourself, I think you can do it based on the recording later. But yeah, so far, like we've installed the v4 periphery dependency and we added these couple of configurations to our Foundry Tomo. And follow along with it. There is a GitHub repo. I will drop the GitHub repo link shortly. It might also be in the YouTube link that's already there from like a previous workshop recording. But I can drop a GitHub link later once we're done then. And then you can follow off of that. Cool. Actually, let me see if I already have something. No, okay. I'll drop a GitHub link shortly. Cool. So we configured that. We're gonna go ahead and do first points hook.sol. Okay. I'm just gonna fix license identifier IT, and we're gonna use any Solidity version basically above like 0.8, 0.25. In our case, it's gonna be 0.8, 0.26. And their contract points hook, right? So the first thing you kind of want to do every time you're building a hook is there's this base hook contract that comes from the v4 periphery dependency that we just installed. And I'm going to show it to you in just a second. But we want to basically import that and we want to extend that and build on top of it, right? So base hook, it's an abstract contract. We're supposed to extend it, and basically just contains like the skeleton of what a hook contract can contain, right? So it contains like skeleton empty function definitions for every single hook function that you could implement. You don't have to implement all of them. Obviously, you can like, if you're only implementing a single function, you can just do that and not worry about the rest. But it contains this, skeleton that's nice. We can extend, and it takes care of like some basic validation for us. So we're gonna extend base hook. And the other thing I'm just gonna also import is I'm gonna import ERC20 because we want to use that to mint our points tokens. So I'm gonna import ERC20. You can get that from Soulmate. You can also use OpenZeppelin, that's fine. But Soulmate comes as a dependency of V4 Periphery, so we already have it downloaded. So you can also extend ERC20. And we'll do our constructor. And so one thing the base hook needs the address of the pool manager in its constructor, which is the Uniswap v4 pool manager. So we're going to take that from our contract and just pass it forward. Also import the interface for the pool manager so you can use it. So v4 core interfaces pool manager.sol, and we'll grab that from here. We'll just forward it along to the base hook and also initialize our ERC20 token. We'll just call it points token, ticker is point, and 18 decimal spots. Cool. Then if we go back to base hook for a second, then one thing that every hook project also needs to do, so regardless of like whatever combination of different hook functions you're implementing, the one thing you always need to do is you always need to implement this function called get hook permissions. So what is get hook permissions? It's a kind of a read-only function that returns this hooks.permissions struct. And what that struct contains, it basically contains, all the possible hooks that you could have implemented, and you just do like a true, false, for whatever functions you have actually implemented in your hook, right? So if you're only implementing, let's say, before initialize, you'll do true for before initialize, and everything else you'll just return false. So I'm gonna import hooks here. We can have access to that struct hooks.sol, and let's write out get hook permissions. Public pure, and returns the hooks.permissions struct. So return hooks.permissions. Now, going back to our README for a second. So we discussed what we're going to do is we're basically going to give out points every time somebody does a swap where they're spending ETH to purchase the other token in the pool. So when you think about that in terms of hook functions, like what hook functions might be relevant to us for building something like that, and we know we have like these 14 hook functions that are available that we can use. There's two over here that seem relevant, right? It's before swap and after swap, because we're minting points every time somebody does a swap. So it makes sense to try to do it inside either a before swap or in like an after swap, right? Today we're gonna go with using after swap. The reasoning for that is once the swap is complete, right? When we're in after swap, once the swap is already complete, we know, the exact amount of tokens that were swapped. Whereas you can kind of think of it like, because there's slippage, right? So initially you can kind of think of like Alice is like, I want to spend 1 ETH to purchase some amount of token, or she's like, I'm going to spend, up to 1 ETH to purchase exactly 50 tokens. and there can be slippage, the price can change. So we don't know exactly how many tokens actually got swapped until after the swap is done, right? So because we want to be kind of accurate here, and we want to kind of, we're basing off how many points we want to mint based off of how much ETH was spent. So we accurately want to know how much ETH was spent in the swap. So we're going to use after swap for our use case today. So basically in hooks.permissions, everything except for after swap, we can just return a false. So I'm gonna go like this, take all of these. So we'll just do false for everything, and then after swap, we'll do a true, right? This is a hook function we're gonna implement, and we're not gonna implement anything else for today. Cool. I'm going to quickly pause here. Any questions about anything we've done so far? So this is like basic boilerplate hook code. Every hook project needs this. You might not need the ERC20 thing for your hook project. Of course, like that's not mandatory, but the base hook and the get hook permissions function is basic boilerplate. Every hook project is going to need that. Any questions so far about what we've done? Okay. Cool. Then what I'm gonna do now is I'm gonna create a dummy function for after swap implementations. I'm just gonna write out the function, and we'll come back and write the logic for it in just a second. So you can also get that from base hook. So we go in base hook and we look at, after swap. There's this underscore after swap function that is marked virtual, that we need to override, right? So in our case, I'm just going to yoink this from here, and mark this override, and we're going to come back and do this function. And it takes in address sender, pool key, swap parameters of the swap that just occurred, the balance delta, which contains, how many tokens exactly got swapped, and some arbitrary hook data that the user might have sent us. Fadil, I see you've raised your hand. Do you have a question? And just drop the question in chat. Okay. Okay. Well, so we'll come back. We'll finish this up in a second. And let's go back to our README now, real quick. So let's think about high-level design of how this is going to work. Right, so you can imagine Alice. Alice does, does a swap on our hooked pool. Inside after swap, our hook is going to check a few things. Firstly, it's going to check that we are in an ETH XYZ pool of some sort, i.e., ETH is one of the tokens in the pool. Then secondly, we're going to check that Alice is spending ETH to purchase XYZ, because if she's spending XY, if she's like selling the XYZ token for ETH, in that case, we don't want to give her any points. But if she's buying the XYZ token and spending ETH to do that, only then do we want to give her points. And then thirdly, we're gonna figure out exactly how much ETH Alice spent and calculate amount of points to give her accordingly. And then lastly, mint points tokens to her, right? Okay, there's a question in chat. Okay, like on Uniswap v3, we can get predetermined values of the expected outcomes on Quoter. The output of amount out. You can use the coder for like V4 has an equivalent coder library as well. So like if you're using it for like off-chain calculations, like simulating how much a swap is going to give you, like an estimate, V4 also has a coder library, so you can use that. But if you're operating inside a hook, then you know like exact values by the time we get to after swap. Because by the time you get to the after swap hook, the swap has already happened. So you know exactly how many tokens were swapped, like how much, what the input amount was and what the output amount was. You know the exact amounts at that point. Cool. So we're gonna do this, and then what we're also gonna do is we're gonna create a little helper function called let's call it assign points that does the actual token minting. And here we're going to take a little bit of a detour real quick to understand how do we know who to mint the point tokens to, like what address. Does anybody have any guesses about that? Like if you think from the perspective of a hook contract, um, does the hook contract have like any way to know what Alice's address is? Like can it just mint to Alice's address somehow? If you're familiar with Uniswap v3, you might know the answer to this, even if you're not familiar with v4. Like even if you're not thinking about the hook contract, does Uniswap itself, does the actual like Uniswap core contract itself has any way of knowing what Alice's address is? Any guesses in chat? Just yes or no. Like calling function. Yes, it does know. Okay. Interesting. Okay, so we have a couple of guesses over there. We heard message.sender. Somebody also suggested maybe it's this address sender over here. Um, the answer, like, since I asked that question, you might have that hint already, but the answer is actually we have no way of knowing who Alice is, like who Alice's address is. In fact, Uniswap itself has no way of knowing who Alice is. The reason for that is, first of all, if we think about the flow, like flow of a swap in a hooked pool, right? What are the transactions that are happening? So there's the user, Alice. Alice is going to call some sort of like router contract, right? Like Uniswap's universal router or like a DEX aggregator like 1inch or MetaMask swap or something like that. So she's going to be going through, some sort of router contract where she initiates a swap. This router contract is going to go ahead and call Uniswap. Um, in this case, like for Uniswap v4, it would be the Uniswap pool manager contract. And then the pool manager contract will further call our hook contract. So what this flow implies is if we use message.sender inside the hook contract, this is going to be the address of Uniswap pool manager. So we cannot use that. Then you might say, okay, maybe we can use the address sender variable that's coming from here in after swap that we have it as an argument. So that, however, also isn't the address of Alice. And the reason for that is Uniswap itself has no way of knowing here who Alice is. Because from the perspective of Uniswap as well, message.sender is not Alice. Message.sender is the address of the router contract. And it doesn't have a way of knowing who Alice is. So, one other guess people often make is, okay, maybe we can't use message.sender. Maybe what we can use is we can do tx.origin, and that will give us Alice's address. And that is true, but only in this very simple case. Like that only works. This is like one of the simplest forms of a swap transaction that you can do. So tx.origin works, but only in this very simple case. In an alternative world, in an alternative case, what might be happening is Alice is using a smart contract wallet, like, account abstraction and all that. And a paymaster or relayer of some sort is the one actually putting the transaction on chain. So in that case, tx.origin is actually address of the paymaster, address of the relayer. It's not the address of Alice. So generally speaking, both Uniswap and by extension our hook has no inherent way of knowing the address of Alice. In a general case, you cannot figure it out. You don't have the information to be able to figure it out. So how do we do it? How do we know? How do we know who do we mint point tokens to? And this is where we're gonna actually, I'm gonna pause it real quick. We're gonna talk about here a little bit about this field called hook data. But before there, does this make sense? Does this kind of make sense, like why we don't have a general purpose way of knowing who Alice is? And not even us, like Uniswap itself doesn't have a general purpose way of knowing who Alice is. Yep. Okay. Cool. So since we don't know who Alice is, we don't exactly know who to give points to. What we're gonna do, we're gonna use a little bit of a workaround hack. So what we're gonna say, instead of us figuring out who to give points to, we're gonna have the user specify an address to mint points to. And what this means is, this enables a user to sort of also, like, quote unquote donate their points to someone else if they wish to. And that's fine. We're not going to restrict that behavior because points in our case is an ERC20 token anyway. So they could have just traded it to the other address anyway if they wanted to do that. But basically, we're just going to have the user pass in some random address, and as long as they pass in an address, that's the address that the points are going to go to. It might not be Alice's own address. It might be Bob's address or somebody else's address, but that's where the points are going to go to. And if they don't specify an address, in that case, nobody gets any points for that swap. So hook data is what enables this. So every hook function, almost every hook function, I believe there's like one exception, but that's not relevant. Most hook functions, including after swap, have a hook data argument present as the last argument of the function. Users can pass in arbitrary data to your hook contract through this parameter. And this is very useful for like a lot of different cases. We're going to use it today to, have the user specify a recipient address of some sort. But if you want to think about it a little bit more, like hook data is also very, very useful for example, something like, I don't know if you saw the announcement, but Coinbase recently launched this thing called Coinbase Verified Pools. You can kind of think along those lines of like KYC pools, for example, like institutional grade Uniswap pools, where, for example, you're only allowed to swap if you can present some sort of KYC proof, right? This could be like a ZK proof or something along those lines. So how do you present that data to the hook, right? What you want to do, like your hook ideally wants to, verify that ZK proof. If it is valid, let you do the swap. Otherwise, don't let you do the swap. Right? So you can kind of think of that as like an example use case. And then how do we give the ZK proof to the hook contract? We pass it in via hook data, right? So hook data is very useful when you just want to pass like any sort of random information over to your hook. And what it's going to do, like Alice is going to give her router the hook data. The router is going to forward that hook data to Uniswap, and Uniswap is going to forward that hook data to your actual hook contract. And then here you do whatever you want to do with it, right? The initial first couple of contracts, they're just going to pass it along. There's not going to be any sort of validation on it. They're not going to care about that value. They're just going to forward it all the way to your hook contract, and then you can do whatever you want here. But anyway, so for today, we're going to leverage hook data to figure out who do we mint points to. We're going to do that, all of that stuff inside our little assign points function that we're going to take. So in assign points, we're going to take our hook data, and we're going to take like how many points do we want to give out to this user. And we're going to do a few different checks here. So number one, if there is no hook data, like if the user didn't pass in an address or anything, right? If they forgot to pass in an address. If there is no hook data, no points will be issued to anyone. So if hook data dot length equals 0, you just return, don't do anything. Then if there is hook data, then we're gonna try to extract a valid Ethereum address from hook data. So you being passed like arbitrary bytes, we're gonna try to extract a valid address from it. So we're gonna do abi.decode hook data as an address data type. If it is invalid, right? If they didn't pass in an actually valid address, if it's not like the correct length or is passed in like something completely random, when we try to parse it as an address, it's going to end up as the 0 address. So if it is invalid, i.e. it is the 0 address, no points will be issued to anyone. So if user address equals the 0 address, you just return. Otherwise, we have a valid ETH address to mint points to. There we can just do mint user points, right? And this mint function is coming from the ERC20 contract that we're extending. Cool. This makes sense? Any questions about this function? And we're just gonna like call this function inside after swap here in just a second, but high level, this makes sense. Cool. Cool. So then coming to actual after swap, what did we say we were gonna do? So we need to do these 3 things. Okay. So we're gonna verify. We are in an ETHXYZ pool of some sort. We're gonna verify that Alice is actually spending ETH, and then we're gonna figure out exactly how much ETH she spent, and then assign points to her. Actually, before that, I want to talk about one more thing, which is what are we supposed to return from after swap? So by convention, every hook function you build, this can literally every hook function, I show you in base hook. So in base hook, every hook function you write, regardless of what it is, the first value you return, you always return at least one value from it, and it is always like a bytes 4. Right? You always return at least this bytes 4 value. Some hook functions you need to return more than one thing, and that has like different use cases and different meanings in certain contexts. But the first return value of every hook function is always this bytes 4 thing. And what that is, it's just the function selector for the actual hook function itself. So in this case, it would be like this dot after swap dot selector. And this is used to indicate like success of your hook function. Like, you executed something and it's fine. Like Uniswap can move on and do whatever other thing it needs to do after calling your hook. So you always return the function selector as the first argument. And in our case today, after swap particularly also has a second return argument that we're not going to worry about it today. We're just going to return 0, which is the default value. But this is more of like there's a bit of an advanced use case. It's used for like charging fees in your hook. So like part of the swap that Alice did, you can partially like take her tokens and keep it for yourself as like fees for the hook. We're not going to worry about any of that today. We're just going to do 0, which is the default return value. So let's do step 1. Verify that we are in an ETHXYZ pool of some sort. So how do we know that? So you have this pool key. We have this pool key that's coming in and after. So this tells us what pool we are operating on. This contains like all the information that identifies a pool, right? It's like the 2 tokens, currency 0, currency 1, like the 2 tokens that are part of the pool, the fees being charged on the pool, the tick spacing of the pool, and what hook is attached to the pool. So to ensure that, ETH is one of the tokens in the pool, we can just check that if key dot currency 0 is address 0, because ETH is the native token. It doesn't have a smart contract address, so it's represented by the 0 address. So if the token in the pool, if like the first token in the pool is the 0 address, then we continue. So instead, what we're going to do, if the first token in the pool is not the 0 address, we're just going to return early, and there will be no points issuing of any sort happening over here, right? And this little helper function, I need to import this. It comes from, I'm going to import currency from v4 core types currency.sol. So currency is just a wrapper around like an address, basically, and it just contains some helper functions like is address 0 and like a transfer function and stuff like that. But basically, it's a general purpose representation of native token plus ERC20 tokens. So it just, instead of dealing with them separately, it just combines them into like this one currency type. So if the first currency of the pool is not ETH, let me just return early. I don't need to do anything over here. Secondly, we need to make sure that Alice is actually buying XYZ token and spending ETH, not the other way around. So we can do that by checking the direction of the swap. Right, so if we look at these, well, let me reload VS Code because my autocomplete isn't, like I can't seem to command click right now. Oh, I need to import pool key. Import pool key. Family for the core types. Pool key. That's well, this is the pool key struct I just showed you earlier. I also need to import balance delta. Balance delta. Okay, we're gonna get to balance delta in a second. So we have the swap parameters. This is what Alice told Uniswap she wants to swap. So this contains, a couple of different things. The one we care about is this 0 for 1 value, which is the direction of the swap. So like each pool obviously has like 2 tokens. One is called currency 0, the other is called currency 1. So 0 for 1 means like, are we swapping currency 0 for currency 1? Or are we swapping currency 1 for currency 0, right? So if this is true, if 0 for 1 is true, it means we're swapping currency 0 for currency 1. If it is false, it means we're swapping currency 1 for currency 0, right? And ETH, like native token, is always going to be currency 0 because it is the 0 address. So it's always the first token in the pool if it is part of the pool. And we know, at this point it is part of the pool. So to make sure Alice is spending ETH, all we need to check is if swap params dot 0 for 1 is true. So I'm gonna negate that. So if it is not true, if she's not spending ETH, we just return early and no sort of points are gonna be issued here today. So we've done these two, and now we need to just figure out, now we know she's in a valid pool, she is spending ETH. So now we just need to know how much ETH did she actually spend, and then give her points. And this is where balance delta comes in. So balance delta basically contains, its balance delta basically contains like amount 0 and amount 1, which tells us, how many tokens of each currency were swapped. So amount 0 is like how many tokens of currency 0, and amount 1 is how many tokens of currency 1. And amount 0 and amount 1 are also ints, so they can be negative and they can be positive, and those values mean a certain thing. So I'm gonna, real quick, let's just talk about that. Balance delta numeric signs. So in Uniswap by convention, what happens is whenever we talk about money changing hands, right? Whenever we talk about like tokens going in and out of Uniswap, token transfers basically are always represented from the perspective of the caller, right? The user. So like Alice in our case. So what that means is if a token transfer amount is a negative number, right? Negative implies, like some negative amount from the perspective of Alice. So negative implies money coming out of Alice's wallet and going into Uniswap. And similarly, if it's a positive number, if amount is a positive number, that means money going into Alice's wallet and coming out of Uniswap. Right, so every time you come across like any variable that's supposed to represent an amount of token that was transferred or is going to be transferred, it's always from the perspective of the third party. It's always from the perspective of whoever's interacting with Uniswap. So if it's ever a negative number, that means, they're sending that amount of tokens to Uniswap. And if it's a positive number, that means Uniswap is sending that amount of tokens to that person. So in our case, we know she's spending ETH because we've confirmed her swap direction. So you can figure out, ETH spend amount by looking at balance delta dot amount 0, because we know ETH is currency 0, but this is going to be a negative number, right? Because this is ETH coming out of Alice's wallet. So this is going to be a negative number. So we want to convert it into a positive number. So what I'm going to do, I'm going to flip the sign. I'm going to do like minus delta dot amount 0. So I'm going to flip the sign, make it into a positive number. And then we just need to typecast it into a uint 256. It's currently a int 128. I'm just going to typecast it to a uint 256. Okay, so basically, like if Alice is spending 1 ETH, delta dot amount 0 equals like negative 1 ether. So minus delta dot amount 0 equals 1 ether, right? And then we just typecast it into a uint 256. And then based on that, you can calculate, like points to give equals ETH spend amount divided by 5, 20% of the amount of ETH she spent. And then we can just do assign points, hook data, and then points to give. Okay. Cool. I'm gonna pause here. Any questions about this function? Oops, sorry. Any questions about what we've done over here? Does this make sense? Are we not worried about underflow, overflow, and typecasting? Um, if that was a problem, if that was a problem, it would have failed way before it got to after swap, right? If that was a problem, because Uniswap uses this balance delta representation of things everywhere in the code base. So theoretically, if you were doing a swap that was exceeding the bounds of like an int 128, um, you would have problems way before you get into after swap. Like it would fail way before this point. So no, we're not worried about it. Any other questions? Um, the function of after the swap router calls the pool manager. Pool manager looks at hook contract, which has, yeah, so the base hook implements the external after swap function. Um, Actually, this is a fairly recent change, actually. This only changed like 2 or 3 weeks ago. Previously, we would override the external function directly, but it's a very recent change that they've now split into like an external and internal definition. The only reason for it is the external definition just has this modifier on it, only pool manager, which just ensures that the hook function is being called by Uniswap and nobody else. And then we can just focus on implementing our business logic in the internal function. But yeah, that's the only reason we're modifying like the underscore after swap variation of things. So it already has the only pool manager modifier on it on the external function. So we don't need to worry about checking that in every function that we implement ourselves. Does that make sense? Yep. Okay, perfect. Cool. Um, cool. So at this point, we're actually done with our hook contract. This is it. Like we are actually done with our hook contract. So just to recap real quick, we did after swap. After swap verifies, a few different things. Make sure we're in a valid pool that we care about for our use case. That Alice is spending ETH and purchasing the other token in the pool. We figure out how much ETH she's spending exactly. Calculate, take 20% of that as the amount of points to give her. We call our assign points function. Our assign points function, checks if there is any hook data that Alice gave us, and if the hook data contains a valid address. And if it does, we mint points tokens to that address, right? And then we just return. Uh, the one more crucial thing I want to just quickly point out is uh, note how we are not reverting um, in case our conditions aren't met here, right? Note that when our conditions aren't met, we're simply returning from this function early instead of like reverting. Like normally in smart contracts, typically when you're like checking things, when you're asserting certain cases are happening, typically, if the assertion fails, you want to revert the transaction. In this case, we don't want to revert the transaction, right? And the reason for that is, for example, if Alice was actually selling the XYZ token for ETH, we don't want to make it impossible for her to do that, right? Like imagine if here we did like revert, like something like revert not allowed or something, right? What that would mean, it would make it impossible for Alice to ever sell XYZ token, because if she ever goes to sell XYZ token, we'll end up in after swap, and after swap will revert the whole transaction, and the swap will just fail, right? So we don't want to do that. So just note that you have to think a little bit about where do you actually want to revert a transaction and where do you want to just return from the function and not do anything. There are cases where reverting does make sense, right? We previously spoke briefly about the idea of like KYC pools, for example, where only if you have like a valid ZK proof of some sort of KYC do we let you do the swap. So in a case like this, if we are unable to verify your ZK proof, or it's invalid or whatever, in that case you would actually want to revert and not let the person do the swap. But for our case today, we just want to return. We just want to be like, okay, like fine, nobody's going to get any points, but you can continue doing your swap, right? Um, yeah. Does that make sense? Also, we're pretty much at time, so I don't know if we're gonna have enough time left over to write tests for this live today. But what I'm gonna do is, if anybody has any questions, I can help answer the questions. I'm gonna drop a GitHub link. It just has like one basic test, one basic Foundry test, as just verifies that this actually does work. So let me just drop that GitHub link right now. Give me 1 second. Um, mm, mm, mm. Okay, I'm gonna drop the GitHub link in the Zoom chat. Here you go. But okay, there's a question in chat. So in this code here, if somebody wants to do a swap on pool manager on a pool with points hook attached, then needs to submit hook data in addition to the swap params, which includes the wallet. Yes. And if you don't do it, like your swap will still go through because we're not reverting the transaction at any point. Your swap will still go through, but you won't get any points for it. If you want to get points for it, then yeah, you're gonna need to submit hook data for this. And the only reason we're using hook data here again is like because of what we're trying to do is like minting tokens to a user. And because of the fact that, Uniswap doesn't have a way of knowing who the user actually is. And that's not just a problem with like Uniswap v4, right? It's the same in Uniswap v3. It's also the same in Uniswap v2. The core Uniswap contract has no way of knowing who the actual user is who wanted to do the swap, right? Is that's the router's job. It's the router that knows who the actual user is, and it's the router which is actually transferring tokens here and there. Is Uniswap just sends tokens to the router, and then the router sends the tokens further to the actual person. So Uniswap at best just knows the address of the router, doesn't know the address of Alice. You could use, some sort of like trusted router. For example, if you're going through the universal router that Uniswap has, the universal router exposes a uh, external function called message sender, and you can call that, and it will give you the address of the actual user. But that's only if you want to restrict it to specific routers, because not every router is going to do that. Not every router is going to have that function, or it might return you a fake value, a malicious value. So you can only do that if you're willing to trust specific routers only. But in a general purpose case, we don't have a way of figuring out the address of Alice in our workflow. So we need to rely on hook data for that. All right. Um, cool. Any other last minute questions before we wrap up? Also, I just want to shout out if you enjoyed this, if you want to build a lot more hooks, um, way beyond what we have here today, apply to join the Uniswap Hook Incubator, atrium.academy/Uniswap. The next cohort starts April 24th, and a couple more cohorts as well later in the year. So apply for the UHI incubator if you want to go through a full 2-month cohort of building hooks. But yeah, okay. Does transient storage allow you to store wallet addresses? Isn't that how Flash accounting works between ERC20 contracts? So transient storage can be used to store any type of data, but transient storage is still like, you know, it's still like storage within a specific contract, right? So the only person who knows the user's address is the router. The router can use transient storage to store the user address if it wants to. It doesn't need to do that because, you know, it can just access it via message.sender, but it still doesn't solve our problem where how do we as a hook contract know who Alice was? Like we just don't have access to that information without involving like some level of trust assumptions or restricting to a certain subset of routers only. Like one thing you can do, right? For example, in after swap, you can add like some sort of condition over here that if the sender is not equal to, let's say, address of like universal router or whatever that is on whatever chain you're operating on, then you kind of like return early from here. And then you know that, you know, the swap is coming from the universal router and universal router is trusted. So here you can get address of Alice by like, you know, universal router dot message sender or whatever, right? This is pseudocode, of course, but you know, if you want to restrict it to a certain set of trusted routers, you can get it like that. But that doesn't work in like a general purpose case again. Transient storage is also, by the way, like, you know how we declare like state variables in contracts, like you can do like, you know, whatever, like my var. Um, Transient storage is just like this. It behaves very similar to just like a storage variable in your contract. The only difference being that storage variables actually like have like an infinite lifetime. Like if you set this value to something, it stays that value until the next time it changes. The only thing with transient storage is transient storage operates on a per transaction level, right? So at the beginning of a transaction, you do something like my var equals 5, and then you can use that value later in the same transaction. But once the transaction is complete and the EVM moves on to the next transaction in the block, my var will be reset to 0. Like the value doesn't persist. Uh, Transient storage values only exist in the context of a single transaction. That's the only difference between transient storage and regular storage. And that's also why like transient storage is cheaper because it doesn't actually live on the blockchain persistently. It's just like a temporary value that exists only within a specific transaction. Transient storage allows you to share data between contracts. Again, regular storage allows you to do that too, right? But that's not the question. The problem we're still facing is you still need to make the assumption that the router implements that, right? You still need to make the assumption that the router is doing that. The router is using transient storage or regular storage or something to share that data with you. And it's doing it in like a trustworthy way, right? It could share you a fake value. It could share you like a random scammer address to farm points, right? There's still like trust assumptions that get introduced. It's the same thing as like calling message sender on universal router. You know the universal router is trusted because it's open source, it's audited, it's out there, anybody can look at the code. So if the swap is coming through the universal router, you can use it, but that's not true for arbitrary router contracts, right? Because anybody can build a router contract. So and swaps can come from any router contract, and not every router contract is necessarily going to tell you the truth. So the problem just comes back to the same thing, right? There is no general purpose way of getting access to Alice's address without involving some sort of trust assumptions in the process. Yep. Cool. All right. Cool. Hope you guys had fun. If hopefully I'll see some of you over in UHI at some point. We're gonna go through a lot more of this. Next week, I believe we're gonna have an interview with Semantic Layer, who's a previous UHI cohort. team who took part in a UHI cohort, an earlier UHI cohort, and they've gone on to become one of the most successful Uniswap hooks on mainnet today. So that's pretty cool. Um, or sorry, they're sorry, I confused them. Uh, they're going through audits right now, and they're going to be deploying on mainnet very, very soon. They're just getting their hook audited, I think. But anyway, we have them coming, interview next week, same time, Wednesday. So check that out. You can find the event on Luma. And cool. I shall see you guys soon. Have a great rest of your day, and thank you so much for coming, everyone. Cheers.